So today we'll be discussing how to do the first derivative test. So you'll let c be a critical number of f that is continuous on an open interval I containing c, where c is a number. And if f is differentiable on the interval except possibly at c, then f of c can be classified as the following. So if f prime of c, your derivative of your function, changes from negative to positive, then f of c is a relative minimum of f. However, if f prime of c changes from positive to negative, then f of c is a relative maximum of f. So here's how you use the first derivative test. First, you have your function f of x. Then you have to take the derivative of that function, and you have to find the critical points. Critical points are any values at which the derivative is either equal to 0 or undefined. And then you have to check those critical points to see if the derivative is changing signs at those points. And you must also include your endpoints when you're checking for mins and maxes. So now we're going to do a quick example of the first derivative test. So first you have our function f of x equals 3x squared plus 4x plus 2. So now we have to take our derivative, which comes out to equal 6x plus 4. And this isn't defined on a closed interval, so we don't have to worry about endpoints right now. And we're going to find the critical points of this function. So we have to set this equal to 0. So when you set this equal to 0, you get that x equals negative 2/3. And to find if it's changing sign at negative 2/3, you can do a quick chart. This is if you're not using a calculator. So negative 2/3, that's where f prime of x equals 0. And then any value when x is less than negative 2/3, the value is going, f prime of x is going to be negative. And any value that's greater than negative 2/3, any value that's greater than negative 2/3 for f prime of x is going to be positive. So by the first derivative test, there's a local minimum at x equals negative 2/3 because f prime of x is changing sign from negative to positive at negative 2/3. So here's another example of applying the first derivative test. Typically you'll see this on an AP test. So we're given a graph of f prime of x. And so now we find where the function is increasing and decreasing. This is f prime of x. So to find where f of x is increasing, it's anywhere where f prime of x is above the x-axis. Anytime where f prime of x is positive. So in this case, f of x is increasing from a to b and also from e to f because f prime of x is positive. And f of x is decreasing from b to e because f prime of x is decreasing. It's below the x-axis. Alright. And also we need to check the critical points and where there's a min and max of this function. We've got to still apply the first derivative test. So for the critical points, it's anywhere where f prime of x is equal to 0. So f prime of x is equal to 0, as you can see at points b, c, and e. However, only points b and e will be a relative min or max because f prime of x is changing sign at those points. At f prime of c is not changing sign, therefore it cannot be a relative min or max. And also for the min and maxes, there is a relative maximum at points b and also at point f because at point b, f prime of x is changing from positive to negative, and at point f, that's the extra endpoint, and the values before is increasing. There's a relative minimum at the origin and also at point e. At point e, because f prime of x is changing sign from negative to positive, and also at the origin because the values immediately following are increasing. And that's how you use the first derivative test.